Hello! Elegoo sent me this robot kit here for review. This is not a sponsored video. I'm not connected or affiliated to Elegoo at all. They just sent me the robot so I could review it. So I'm gonna give my honest review. And this is very handy because I was already planning to build something similar to this robot in order to connect it to an LLM and some AI to see if I can get a robot to behave in a more like sentient way. So this is gonna save me some time. So if everything goes well in this review, let's see if it works for that project. And anyway, even if it doesn't, I'm gonna review this. I think it's gonna be pretty fun. Here we are. By default, I think it has some software already installed in there, or some software available whenever, I don't know, I never used one of these before. So basically, obstacle avoidance mode, infrared remote control mode, line tracking mode, auto follow mode, FPV mode. Well, it's pretty cool. Okay, here we have the assembly tutorial. So let's see what it has inside. Different screws, the remote controller. I think this is the main chassis for the robot to keep everything together. And USB cable, motor, wheels, sensors, everything. All right, let's get into it. So the first part will be to remove the protective film before assembling. So this is one part, and then assemble the motor. Let's see where is the motor. Not here. These are the boards and sensors, and not this one. It's heavier. I think this is the motor. Yeah, there is one servo here and other stuff, but for the battery, it even brings the electric tape. That's nice. Anyway, so far the packaging looks very cool, very nice, very well organized and everything. Here we have the remote controller, USB cable, the motors and the wheels. It's very nicely packaged. That's, I must say, really it's very cool so far. So here, yeah, take 1, 2, 3 out from the bag marked for motor. This is 1, 2, and 3. Take this out of the bag. It even brings screwdrivers as well. It brings everything. So I need these, then this aluminum block here. One piece is also located here. Let's take the motor first. So this is the access that goes there. Simple motor cable. And let's see what is next. So basically I need to get 2 of these here through the motor. There is a hole here. I will go through it and then assemble here on the aluminum part, and then there is a bolt there on the other side, then sorry, the nut in this side here that is gonna get the whole thing together. And in this picture is actually in this direction. This little bump here, it's a little thing on the surface is here, so it should be in this direction as is here. So let's do that. So we have here, this part seems to be the same on both sides. So this goes on this side here, and then we take one of these guys and they go through here, and they should go through that one. And then the other one does the same, goes here and here. And then I'm gonna put the little nut. Just to get things properly tight, I usually do these. I like to make sure that, yeah, there. Because with your fingers, it's not the same. I think it was okay, but this is something I like to do. So that's one. Let's do the other ones. Okay, this is all done. Now let's see, the next step is we need to take this guy here, and first we need to remove here the film. Okay, based on the image, we need to use this one, which will be this one here. So let's remove the protective film. It is not easy to remove. It would be nice if I know maybe it's difficult for the manufacturing, but if we had a little bit extra here. So basically it would be just pick that up and pull it and take it out, that instead of going through this process. Anyway, it's not a big deal. Done. Now next step is to get the other screws. Look at that, it's very nice. It's already written there in the bag, the screws and the nuts, everything that you have. That's perfect. So I know already what I need to use. This is very nice. Okay, so this is M310. Here is M310, 8 pieces. They are here. Perfect. You see these ones? That's the one where the screw is gonna get when you put it in these holes here. So that goes there like that. Interesting. That's the thing, you never know where these things are going, why they're there, and then when you start building it and you figure out, that's why we need to do this thing here. That initially looks kind of useless, but no, it isn't. There is a reason for it. And keep an eye that they go in different directions, as the picture is showing here. As you can see, one is pointing in different direction than the other one. So this one goes, yeah, it goes like this. Cool, all done. So now we have the 4 motors in there, and looks pretty much the same as the image here. Next, assemble the line tracking module. And here the line tracking basically has a photo cell, and it will tell when there is a line or not. The light that comes from to the photo cell will change, and that will help the robot to align, understand where to follow a line. Okay, so based on the picture we have, it goes in this area here, as we can see, and the connector is not visible, meaning that it's going in the back. And of course the sensors have to go in the front and pointing towards the ground. Next we have assemble the expansion board and Arduino. So here it is. This one is M3 5, 11, and here we have 5 and 11. So next we take the expansion board, and here is the GY521 module, which is basically an accelerometer and a gyroscope, this tiny thing here. And this one here is the expansion board. And we take this copper pillar, this pillar here, and one of the tiny screw goes under this side. The pillar goes here, and then the board is plugged here in this way, there, and then another screw on top that is nicely solid connected there. The little bit of change of scenery and t-shirt and everything is because this is another day. For the next part, it looks like now we are gonna assemble the Arduino Uno with the rest of the unit. And by the way, what I'm holding here in my hand is a PCB, which reminds me of our sponsor PCBWay. Starting from just $5, you can submit your PCB designs and PCBWay will take care of absolutely everything, manufacturing them with the best quality you can get in the market, and they will be delivered to your home. There is not only just PCBs, but also 3D printing, CNC. They have also tons of open source projects in their website, which you can just get delivered to your home and build your own kits. Check out the website, and thank you PCBWay for sponsoring this video. Okay, so apparently I need to get the second board. which is going to be the A one as indicated here. And in that board, the Arduino is going to be assembled, and on top of that, we will put the expansion board on top of it. So based on the picture we have, this is the position it should be. We have these 3 holes here, and the Arduino should be be in this position. In this case, be careful when you screw these ones, because you might damage the PCB. Now we have the Arduino already in place, and what we need to do is place the expansion board as indicated here in the picture. This way, press here. Be careful to make sure that they go exactly there. None of them is out of the hole, and gently pressure, and it's done. Now the battery box. So we need 2 nuts and 2 M312, which I have just 2 here. And this goes, take a look at the picture. Yeah, it goes there in these 2 holes here. There's going to be an status indicator light. The light is green when charging and will be turned off once fully charged. And then we have a power switch and the USB charging port, which is all here. USB charging port. This hole here, I would imagine it's going to be the light as indicated here, and then on off is here. Next, assemble the camera module. Here is this one for camera. So this is the camera bracket. I have the screws, the pillar, and the camera module. Okay, here we have the camera module. You can see this little plastic here is to protect the camera. So once everything's installed, I just gonna pull that and remove that so it doesn't get damaged, the tiny lens that is there when we assemble it. And also the cables. So I think I only need one of these because they sound like this is 5. I need the one that is 4. This one here is 4 cable. So let's do one thing at a time. So here we have the bracket, the camera, so screws, bracket, pillar, camera. So the bracket should go based on these, because it's in this position with this bended part looking towards that direction. So here is assemble. Apparently you can use also this with a USB-C. I haven't done any research, so I'm not sure what I'm saying here, but I see a USB-C here, so probably you can even use this camera as USB-C. Not sure. If that's the case, that'll be very, very cool. So next, assemble the ultrasonic sensor module. Now let's get the other screws. So now we have this guy here, and it shows like the 3 holes here and this position. So I think it fits inside of this like that, and then it will fit like this. Okay, look, I made a mistake, so be careful you as well. I'm gonna show you now. So as indicated here, we have these different screws, 1.6mm and 2mm and 3mm. So obviously the 3mm here is the bigger one, and then there are these other 2 screws here that you can see the difference is very small. So I was making a mistake and I was using the tiny one. But that tiny one, you need the nut that is dark and tiny. Then this is how it should look like this. Now the next part is to use the ultrasonic sensor. And this goes here in this panel. And here we only put for now the screws in the lower part. Now we have the ultrasonic sensor. Next, assemble the ultrasonic sensor module, and we assemble these with the camera. Now here's how it looks like. And now the cable here, be careful it doesn't go here this way, because it will interfere with the ultrasonic module. That's why there is this hole here behind, so you can put that like this. 1 eye, 2 ultrasonic sensors, and looks like these are the eyes. But no, this one is a cyclope. Okay, now that we have that, we have these assemble the ultrasonic sensor module. So now we put that here. And for that we need 3 nuts, 3 screws, the big ones, and the whole thing goes using these 3 holes that you can see here. And that's why this shape is here for. To go this way. First we put the cable, obviously, and then it fits in here. So now it starts to get some shape. Now it looks like something is here. We'll see, we can imagine now the wheels, the battery here, the sensor going around with the camera, the brain. So let's keep going. Pay attention to the direction of the servo wiring, it's saying here. So basically we have, this is how it looks like from the picture in this way. And so we have the camera module goes here in the first one, this one here. Then the ultrasonic one goes in the second one. So we have indications here in the board. I don't know if you can see in the camera, but it's UART, then ultrasonic. So everything is explained. So for example, here's the ultrasonic. We're going to put it here. The camera module goes on this one here. And the servo, as indicated here, that goes under this hole. We have in the board, we have one servo, servo 1 and servo 2. And as indicated here, you can see that the servo for the ultrasonic goes on the lower one. Here you have indicated ground and positive. So look at the colors here. Black is going to be ground and red is going to be positive. So you put it in this way, like this, in the servo 1. That's done. The connectivity of this and the battery goes here to this one, which is the two connectors. So you have ground and positive like that. Now it's connected. Just make sure the battery is off just in case. So we operate with this off now. I don't want to turn it on while I'm still plugging stuff in. Okay, keep that in mind. Okay, here is more about the wiring, and now we take the board with the motors. So we put this first and then the screw under it. Okay, all done. Now it has the pillars there to keep it in place. Now in this picture it's showing us how to wire the motors. So these already get assembled one to another. So here I say, please pay attention to the corresponding wiring ports of each of the 4 motors and do not plug in the wrong one. Yeah, because that is gonna, you don't want the robot to start going in one wheel's going in one direction, the other one is going in a different one. Yeah, you don't want that. So they have to go in the right place. So after reading the instructions, is these 2 screws here, this is the front of the robot, because here you have the light detectors, basically the photocell that is gonna understand when following a line. So this is the front, meaning that if this is the front, this is gonna be the right, this is gonna be the left, this is gonna be the right front, this is gonna be the left front. So, and this is going to be also the front. So this is going in this position here. So in the PCB here is indicated right and left. And then we have in this wiring diagram, we have right front port M2, which is this one here. Right front goes here and connects to M2. Now I'm gonna proceed to screw. There's one missing one. Yeah, the 5 cables one. These 5 cables here, it's for the lights. Here we need to connect this guy here, this connector, and then there's a hole here. We'll go through this other hole here and goes here to the control board. Now we can assemble and put the screws. When I do these sorts of things, I like to always get diagonals first, like this. So that helps me to get things aligned since the beginning. So everything else is gonna just fall in place. Cool. Look at that. This is already getting there. So now the wheels. So these have these long screws here. This is a plastic one, means they're similar to the ones you use for wood or something. It means that it's gonna screw directly here to the plastic of the rotor. So yeah, you see here that the shape is kind of square. The shape here is kind of square. So you just need to get in there and push it there. Here we are. Build it. Done. Look at that. That looks so cool. Now let's test the thing if it works. Well, in the remote controller, based on the instructions, it's quite easy. So basically we have here the different directions that you can move the robot. And then we can have line tracking mode, stop is the center one, the obstacle avoidance mode, auto follow mode. And then here you basically increase and decrease the threshold for the line tracking mode. So let's start moving it just normally. It's quite fast. It's very fast. So if you're in a small room like I am, well, there's not much maneuvering that you can do because it really goes very fast. But with the number 9 and 7, you can reduce and increase that speed. After reducing the speed, you can see it's a lot more maneuverable. Now let's see how it works with obstacles avoidance mode. I place some obstacles in there and now the number 2. It gets a little bit confused, but it does the job. Actually, it's avoiding the obstacles. Sometimes it just bumps into things, but I mean, it's not bad. I think it's too fast, the default one. It should be, if it was lower, I think it would do a better job. I'm trying to reduce the speed with the number 9, but apparently in obstacle avoidance mode, it doesn't work. The speed is always the same. Forgive the change in audio, but I have to switch to different microphones as I record this. Maybe next time I will use a lavalier mic to keep it more consistent. In line tracking mode, to get the best performance is having a white background and a black line, or at least the floor should be clear enough to create proper contrast. That's why the kit comes with a black tape included. I don't have white floors, so I have no choice but using this table. As you can see, the line tracking mode works well. I tried experimenting by drawing a line with a marker, but it didn't work well. It gets confused because it should be a complete black line with no interference. Although the threshold can be adjusted, it doesn't really make much difference. Maybe if I had a thicker marker, it would work. I also tried using a white line with some tape, but it didn't work most of the time. Now let's see the auto follow mode. It does follow, but again it is too fast, so it's hard to keep up with it without running. Also, I noticed that it doesn't turn, it just follows on a straight line, which makes sense because after all, it's not using the camera for this, but it's using the ultrasonic sensor to determine if there is something ahead or not. Now let's take a look at the app. First, you need to switch the button on the board to cam mode. Then you need to connect your phone to the Wi-Fi called Elegoo and some numbers. Once you're connected, you can then open the app. It has a remote control, programming, build, do-it-yourself, manual and video. The remote control is very cool, it's my favorite because it allows you to use the camera and you can see where the robot is going and it's very easy to control the speed from there. The response of the joystick on the screen is also very fast and the image has a decent quality and it can also be adjusted in case the connection is slow. In programming mode, you can use Scratch to program it. In build, you have all the building process to assemble the kit. In the DIY mode, you can configure the car functions to debug and see the commands sent and received. Finally, we have a manual and video tutorials. I think in overall conclusion is it is worth getting it. I love it. I have fun building it and it's packed of sensors here for the infrared ones, the ultrasonic, the camera, the Arduino, the controller, accelerometer and gyroscope. It already has all the motors in there. The whole thing is done. The lithium battery that can be recharged. I think it has everything. I think the instructions were very useful. Everything is packed, indicated, shown. Everything is good. So in that sense, yeah, I approve. Basically, I like it. I have fun with it. Now, things that I think could be better would be, in terms of the price, I think it's a little bit on the high part of it. Be nice, be maybe lower, but anyway, there's a lot of these components that you can buy and everything is already made for you. So I think it's a fair price. And another thing is here on the wheels, this screw. As you saw in the video, they go directly into the plastic, and that's something if you try to remove these wheels very often, and by screwing and unscrewing it, it will end up damaging that, and that's very difficult to repair. You will end up gluing it in the future. So It would be nice if that was metal. I know it would increase the price, but yeah, that's one thing. Another thing that could be improved would be the app. I think in the iPhone is interfering with the top notch, and that's something that could be easily adjusted to at least show all the buttons. Some of them were covered by it. And also the app in general would be nice to have a little bit of redo in terms of usability, but it was good enough to get the job done. One more thing would be to have the default speed of this lower. That would be nice, because at the beginning it's quite too fast, especially if you have a small environment, you can play with it like I have here. Starting really that fast doesn't give much an opportunity to maneuver around. So that would be nice to have a lower speed, and then you can increase it. But anyway, that is minor things. For the rest, it's very cool, it's very nice, and it's highly hackable, these things. You just can also program it yourself, not just through the app, but also directly to the Arduino board. Everything is here. You don't have to build anything in particular, spend time in 3D printing parts or anything like that. Everything is here. So I think it's very easy to hack and do whatever you want with it. So overall, yeah, I like it. I think it's a good quality, well built, nice instructions. Yeah, good stuff. Thank you for watching. See you next time.